So this is 10.1, problems worked out. Unfortunately, for the first few, there's not much to work out. It says replace this expression that will generate this series, right? So we look at it, and it's alternating. One will give us to the 0 and 1 minus 1, and so it's positive, negative, positive. So that takes care of that. And then here we have to figure out what we're going to put in. So the first one would be 1 and squared, 2 squared. Oh yeah, that works. So we just go with the star is n squared. Then over here, they change it to 0. Remember I said, hey, we're just going to flex around and play with this. Star is, if it's 0, then it's n plus 1 squared. And down here, we got this n minus 2. It starts, well, the star is over here. So we want to make this 2, if I'm not mistaken. 2 minus 2, no, that's 0. We can't do that. So make it 3. Star equals 3. This is a nice little exercise. See if you can start picking up on this sort of stuff, how it all fits together. So back here, we've started at 0. I like to label the terms. If that's 0, this is the 0th term. And that's a horrible expression, but what are you going to do? And you got 3 9s. We're multiplying by 1/3 basically. So that makes it a little bit easier. Now this is something I've been doing wrong. This is the whole series. They want the nth term out here, so they want to have this sort of thing. 1/3 to the n, plus 1/3 to the n. That's how they really want you to write it. I've been doing it wrong on my notes, and not even wrong as much as just doing the first term versus the whole thing. So, they'll do that, which equals, and I'm not going to do it all over because I'm only supposed to write the nth term, but equals sum from n equals 0 to infinity of 1/3 to the n. So 0 is 1 and 1/3 1/9. Yeah, that works. So again, I like to label the terms 1, 2, 3, 4, 5. All right, we got that alternating thing in here. So we're going to have a plus -1 to the, now we can do n, no, we can do n minus 1 or n plus 1. I'll go with n plus 1. Doesn't really matter. Over 1 times 1/n. All right, and I could again write it n equals 1 to infinity of -1 to the n plus 1, 1/n. So that's the nth term. That's what it's asking for. And this is the actual series notification itself. So again, 0, 1, 2, 3, 4 plus, looks to me like it's 5, and then it goes down by 0.1/10 really. So 5, 1/10, and 0. I go to the 0th here, that's 5. Yeah, that works. N. All right. Fun times. Is this series the same? So what I recommend doing for this is writing it out. This one is 1 minus 1/2 plus 1/4 minus 1/8, ... And when I blast this out, I get 1 minus 1/2 plus 1/4 minus 1/8, ... So that's the same. Over here, I get -1 plus 1/2 minus 1/4. This is different. All right, problems 5 and 6, pick the limit of partial sums, blah, blah, blah. So first two, we get 1. then 3 we get 2. 4 we get 1. 2 minus 1 is 1. This one is 2 minus 1. Yeah, so this diverges. Over here, rather than make this mess, I'll just go with 3, 3.5, 3.55, 3.555. And I don't have to say what the sum is. I just have to say that it converges. If you want, you could say that's 1/100th, so it's 3. Yeah, well, that's weird. No, how do we get from here to here? So yeah, we actually can't do the sum. We could do the sum. We'd have to do this infinite series, find the sum of this, and then add it to 3. But didn't ask us to, so I'm not gonna. All right, for 7 through 10, converges or diverges. If it converges, it's got to be geometric and find the sum. Well, this one is just getting bigger and bigger, so I'm not messing with it. It just diverges. Yeah, I will. It's 1, -1, 2, -2, 3. We would say this is oscillating and accelerating. It's getting bigger and bigger and bigger. I don't care. It diverges is all I care about. Now, here your R is greater than 1. So R is greater than 1, which means that it diverges. If you wanted to write out the partial sum, go right ahead, but I'm lazier than you are. Down here, oh, we've got this you multiply by -0.1. Well, R is -0.1. That's fine. That's less than 1. Starts at 3, and it's just going down by that every time. So sum is 3/1 minus -0.1, which is 3/11/10, which is 3 times 10/11, which is 30/11. Check it with a, check it with a calculator and see what you get, but it'll work. And over here, this is not geometric. It's going up by n/n plus 1 every time. So if we were to add them up, we'd get 1/2, then we'd get 7/6, 3, 4, yeah. Then we would get, let's see, 23/12. So here's the fun part. If we were doing sequence, we'd say this is getting closer and closer to 1. Since it's series, the sequence is not going to 0, it diverges. Got to go to 0 so that we're adding up 0 eventually way out there. If we're adding up 1 way out there, then what's the point? Or 2 in this case. I think it's getting closer and closer to 2. Oh no, each term is getting closer and closer to 1. The sum is never getting closer to anything, which is why it diverges. All right, find the interval of convergence, which I said we're not really ready for that, so we'll try it. We'll see how it goes. So R equals -x plus 1, which you might be like, whoa, where'd you get the negative from? Right here. It says it's alternating. It's basically, you can shove this inside or you can leave it out. So that's hard to see. Okay, well then -1 is less than -x plus 1, less than 1. Get rid of the negative. When we do that, everything flippy flops. So it's just basically -1 is less than x plus 1. It's less than 1, which bothers people. There's an intermediate step here I skipped. We divide. When we divide, we flip. So we get this actually. 1 is greater than x plus 1 is greater than -1, which I just transferred to that. So yeah, get used to it. Subtract 1, -2 is less than x is less than 0. All right, now careful. What's the interval of convergence? There it is. And then what's the function represented by the geometric series? So what? Isn't that the function? No, that's a series. How do I know what a function is? Well, it's the first term. We plug in 0, 1, 1 over 1 minus negative x plus 1. 1 over 1 plus, so it's x plus 2. Haven't really shown you this yet, so that freaks a lot of people out, but that's how we do the problem. Hey, what's the function? Well, we'll just do the whole, turn it into a function using the concept of sum of a series. All right, here r equals, no alternating, x minus 1 over 2. So we'll go up here and do that whole thing. Multiply everything by 2. Negative 2 is less than x minus 1 is less than 2. Add 1. Negative 1 is less than x, less than 3. There it is. That's our interval. Oh, what's the function? Careful now. First term is 3. 1 minus x minus 1 over 2 equals 3 over 2 minus x plus 1. Distribute that negative over 2. I made this 2 over 2 here. Flip it up. We get 6 over 2 plus 1 is 3 minus x. How is this related to this? Yeah, I don't know. What do you mean you don't know? No, I don't know. Notice we have two variables here. N goes all the way forever, and x is still in there. We don't always have two variables in there. It's so confusing. Yeah, I know. We're going to get there. It's going to take some time. Find the values which the geometric series converges, and find the function of x it represents. So multiplying by sine to the power. This is really all right. So I don't know what's going on here. All I know that makes that my r value. Cool. So hey, wait a minute. This works for everything except when sine is either 1 or negative 1. So x cannot equal. We're going forward here, positive. Couldn't we go negative? No, it's n is forward. Oh, wait a minute. What about, yeah, I'm confused too. Pi over 2, 3 pi over 2, right? 0. Why don't I have 0 in here? Oh, 0 is fine. I just can't have 1 or negative 1. 5 pi over 2, dot, dot, dot. Could figure out a way to write that with that little z is all integers, but yeah, I'm not in the mood. So what's the first term? Well, sine of x 0 equals 1. So f of x equals 1 over 1 minus sine of x. And while I'm at it, let's talk about the interval. So as long as x does not equal 2k minus 1 over 2 pi, k is all integers. So that's kind of how I figured out to go 1, 3, 5, 1, put in 2, I get 3, put in 3, I get, yeah, you know. No, I would not expect you to know how to do that. Nor would you have to do that for the AP exam. But hey, we're just keeping you on your toes. Negative 1 less than tangent of x less than 1. Arc tangent negative 1 is negative pi over 4. Arc tangent of 1 is pi over 4. Tangent to 0 of x is 1. Anything to 0 is 1. So here we go. Now the function is 1 over 1 minus tangent of x, comma. Now that's where we get goofy. Negative pi over 4 plus k pi is less than x is less than pi over 4 plus k pi, where k is all integers. Apologize for doing that to you. You'll never have to do that again. So don't lose any sleep over it. It's not the end of the world. Should be, yeah, last page. So I did not want to destroy people with these problems, so I tried to suck some of them out. All right, here we go. So for problem 15 and 16, use the series and the function that it represents from exercise 11, find a power series for the derivative. Well, exercise 11 was f of x equals 1 over x plus 2. And that was the sum from n equals 0, infinity, negative 1 to the n, x plus 1 to the n. Okay, well, f prime of x equals x plus 2 to negative, so negative 1 over x plus 2 squared. Now at this point, you might say, well, how do I take the derivative of this? And the answer is, you don't. You get this derivative and you start playing with this to make sure it makes sense. So how about n equals 1 to infinity? Because then we'll go n negative 1 to the n again. Could have left it at 0 and changed this. Okay, well, hey, wait, we can take the derivative of this. So that's just n times x plus 1 to the n minus 1. Does that make sense? Yeah, it makes sense. We also remember the negative 2 is less than x is less than 0. It's the only way that this function will work. Don't need it for this. Actually, you need it for this. You need it for both. If it's any bigger or smaller than that, you're out of luck. So wait a minute. Let's slow this down. I changed this, and it is what it is. Let's see if this works. Put in 1. Yeah. Put in 1, 0. So this is all just 1. Well, wait a minute. I have to know what the x is, and yeah. So it's very, very confusing. This, by the way, is a colon, semicolon. But for now, just take my word for it. F of x equals 6 over 3 minus x, which is the same as sum from n equals 0 to infinity, 3 times x minus 1 over 2 to the n. F prime of x equals negative 6, 3 minus x squared equals sum. There's no alternating thing here, so I'm going to leave this infinity. And maybe I should change it to 1. Yeah, it's fine. N comes out front. I'm going to pull the 2 out. Why? Why not? Because it doesn't get impacted by the change. And then that leaves me with x minus, oops, there's an n here, 3n, x minus 1 to the n minus 1. And like we said, don't forget, negative 1 less than x less than 3. I think I'm going to tell my students not to do these problems. I don't like them. Anyway, for 1718, use a series centered at A. The function represents find a power series for the integral. Oh, this is tough. So look right above. A is negative 1. So we need to do the integral from negative 1 to x. And now we're going to put in these dummy variables. 1 over t plus 2. Remember, it's the original, not the derivative, dt. And that would be the integral, natural log of x plus 2 minus natural log of 1 equals natural log of x plus 2. And then find the power series. So it's a sum. N equals 0 to infinity. Negative 1 to the n. Now we're integrating. So we take that x plus 1 to the n, we add 1, and we divide by it. And we say, don't forget, -2 is less than x. This time we got a weird thing where it's actually less than or equal to 0. Wait a minute, I thought we couldn't do that. Yeah, look at what happens when we plug in 0, you get 1. The bottom's getting bigger and bigger and bigger, so this will actually work. As long as it's alternating. Told you not to worry about that. We'll get to that eventually. And this one above is centered at 1. 1 to 3 is 2, 1 to -1 is 2. So a equals 1. Integral 1 to x, 6 over 3 minus t dt, 6 ln 3 minus x over 2. What happened to the 1? 3 minus 1, 2 over 2 ln of 1 is 0, so I tossed it. Right. Just saving a step since I already did this once. And that is the same as n equals 0 to infinity, 6 over n plus 1. Where did that come from? Yeah, you'll see. X minus 1 over 2. Why don't you pull the 2 out like you did last time? I'm lazy. N plus 1. And look at this interval changes. -1 less than x less than or equal less than. Whoops. This is why is there an equals there? That's 10.5. That's when we get into that. All right, last one. Ball is dropped from a height of 4 meters. So here it is up here at 4 meters. Each time it strikes pavement after falling from a height of 4 meters, it rebounds up to a feet of 0.6 meters. Find the total distance the ball travels up and down. So here's the first. This is 4 up, it drops, and it comes back up to 2.4. And then it drops, and then it comes back up. Keeps going and going. So the total distance, well, there's a 4 at the beginning, just kind of hanging out. And then it's the infinite series, up and up and up. Well, there's also down and down and down. 2 times the highest it goes is 2.4. That's the 2.4 right there, over 1 minus 0.6 equals 4 plus 2 times 6 equals 16 meters. That'll do. Good luck.